So in today's class, as I told you, we are going to discuss about valency. So, but before going to discuss about valencies, so already we all knows that we have drawn. I think most of you have done the homework also. So you people have drawn the 20 elements. The first 20 elements are atomic structures. Am I right, everybody? Please let me know, guys. Yes. And you have written the electronic configuration also. Easy. So, if you have been noticed it, while I am teaching the electronic configuration and as well as this uh, 20 elements, if you have been taken hydrogen to calcium. So, if you have seen there, the number of cells in every atom is not remains constant. Is it right, everybody? Is the number of cells remains constant? All of it? No. So hydrogen is have only one cell. Helium is also have one cell. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Two cells. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Three cells. Potassium and calcium has how many cells? Everybody. Potassium and calcium having four cells. So that is what. So that outermost shell, whatever the shell, it may be a one shell, or maybe a two shells, or maybe a three shells, or maybe a four cells, some XYZ. The outermost shell, which we used to call it as, what is a shell, everybody? Yes, please.
Shell.
Valence cell. Valence cell, not valency. Actually, it is a valence cell. So the outermost shell of an atom is called the valence cell. So we all knows, am I right, everybody? What is the importance of valence cell? Also, we already studied. So you should remember it. For example, if I take sodium, so what is the atomic number of sodium? Everybody, atomic number of sodium 11. By this time, you all should know. So atomic number of sodium is 11. So electron arrangement KLM 2, comma 8, comma 1. So what is the valence cell now, everybody? What is the valence cell? M shell. Clear? Same way if I take oxygen. What is the atomic number of oxygen? Everyone? Yeah, I told you to learn at least 20 elements first. 8. So if you have been taken, so electronic configuration is 2, comma 6. So what is the valence cell? Everybody? What is the valence cell? L shell. Am I right? So that is what. So valence shell you should remember before going to the valency. Next, valence electrons, not valency. From valency only we'll find the valence. Sorry, from the valence electrons only we'll find the valency. Okay. Yes. Clear, everybody?
Yes, sir.
Hmm. So that is what you have to remember. Okay. So valence electrons. So valence electrons means the total electrons. The total electrons. Okay. The total electrons present in the valence cell. Present in the valence shell are called valence electrons. Do you all understand, Amma? Everybody clear?
Yes, sir.
Yeah.
Yes, sir.
So now if I have taken sodium again. So what is the valence electrons, everybody? Sodium valence electrons, how many? Valence electrons. Valence cell, how many electrons? One. Oxygen, what is the valence electrons?
6.
6. That's all. So if you know this, then it is easy to find us the valency. So that is what is our today's concept. So we are going to make it. We'll see that. Okay, clear? All of you?
Yes, sir. Yes, sir.
Okay. No. So keep adding everybody. So first one, we are going to make it valency. So if you want to calculate the valency, you need to know valence shell and valence electrons. So then from that, I already taught you. Now itself again I am saying you. So again same thing. After that we will go to the definition. So valence electrons may be how many present everybody? 1 may be present, 2 may be present, 3 may be present, 4 may be present, 5 may be present, 6, 7 and 8. So if only one shell is there, that shell name is K shell, then maximum number of electrons how many guys? Only one shell and that shell name is K shell and only how many electrons? Everybody. 2 electrons is there. Then also it will be stable in nature. That is a rule we used to call something. Anybody? Only K shell. Yes, please. Duplet rule.
Duplicate.
Duplet rule. So basically atom and any element wants to be stable in nature, it must have how many electrons? Everybody. Yes, please. How many electrons? Any element wants to be stable in nature, it must have how many electrons in valence shell? I already taught you. 8
8 electrons. 8
electrons.
electrons.
8 electrons other than the elements who has only K shell. Anybody having doubt, you can ask me. So now valence electrons. Now let us go for valency. So if I talk about the valency, if only one electron is there, what is the valency? 1. 2 electrons is there, valency is also what? 2. 3 electrons is there, valency is 3. 4 electrons is there, valency is 4. But 5 electrons is there. What is that valency? Everybody. 8 minus 5, which is equals to 3. 6 electrons is there. 8 minus 6, which is equals to what? 2. 7 electrons is there. 8 minus 7, which is equals to 1. And 8 electrons is there. 8 minus 8, what is the valency? Everybody. 0. So,
0.
any kind of elements who has 8 electrons in its valence cell, 8 electrons in its valence cell, it's become stable in nature and they become unreactive. Is it right, everybody?
Yes, sir.
Okay. Clear?
Yes, sir.
Yeah. So if you know this one, you can find it. So remember, those who are having valence electrons of 1, 2, 3, basically we'll say metals. 5, 6, 7, we says what? Everybody. Non-metals. At least learn this. 1, 2, 3, we used to say metals. 5, 6, 7, we used to say non-metals. Okay. Now we are going to enter into the valency concept. It is not simple. So learning definition is very easy, but many concepts will come under this. Types of valencies, positive, negative, how to find it, a lot of things. So write the definition, valency. The combining capacity of an element is called its valency. Or else you can write more simplified one. Sir, I want it exact meaning what is combining. Or you can write the number of electrons. This is the very generalistic, realistic definition. The number of electrons gained or comma lost or shared, anything gained comma lost or shared, anything shared during chemical bond formation, during scientific definition, this is actually chemical bond formation is called valency of the element. Do you all understand what I'm saying? Mari, any doubt? Please ask. So now, boys, everybody clear? Girls also. So, what is the significance of valency, sir? Somebody asked you. So, okay, valency you are saying. So, what is this? What is the significance? Valency will decides the reactivity of the element. Either the C, you might be heard or you are going to study in next year. If you take sodium and potassium metal, if you just even expose to atmosphere, they will catch the fire. If you put in water like a bomb, it will blast like a bomb, sodium. Do you understand? So that is what is called it as reactivity. So suppose if you put a iron, it is not reacting that much. Iron also metal only. If you are putting a zinc, it is not exploding with the water. So that is what how the nature of reactivity is decided by the valency only. So how far it is true, we will discuss that. So that is the significance of any kind of like valency of any atom. So the valency of the elements, the just very few people only will mix. So where decides the reactivity of the element. Reactivity of the element. Do you all understand, everybody? Ma, girls, clear? So how fast or how slow the given element will react is decided by only the valency. So for example, just for example, I'm saying, so let me show you the metal activity periodic table. So in that I will show you, I'll say you how it is, which is more reacting. Okay. So let us, can you able to see the screen, everybody? Now you all can see. Everyone, please respond.
Yes.
Okay, now see. So first element, basically the most highly reactive element, which is not belongs to group one. Basically, I already taught you and again I'm teaching. Yeah. So this is the group one, only two elements, group two, group three, group four, group five, group six, group seven. So totally it is called, forget about it. These are, we will study later. So actually this will fit here, 89 to 104, you can see 90 and it is continuing 103. So this is what we used to call it as, you can notice it here, lanthanoids and actinoids we used to say. So that is, it's not required now, I'm saying. So basically this is our periodic table. So totally we are having seven periods. Okay, and 18 rows, 18 groups. Okay, that is what we used to say. Groups we used to say, columns, rows we used to say. So we have a 7 rows, means 7 periods we have, and 18 groups we have in our periodic table. So in this, the most reactive one, if you have been noticed it, all of you, this is what? Lithium, sodium, potassium, rubidium, cesium, and francium. Here, same way, non-metals also. Fluorine, chlorine, bromine, iodine, astatine, and testamine, whatever it is. Sir, why, sir? Most reactive. After that, beryllium, magnesium, calcium, strontium, barium, and radium. After that, if you are keep on moving like this, the reactivity nature will decrease slowly. Then, compared to after fluorine, oxygen, sulfur, selenium, tellurium, they will react. Sir, what is this? That is what. So, if you have been taken lithium valency +1, sodium valency +1, potassium valency +1, rubidium valency +1, beryllium valency +2, magnesium valency +2, calcium valency +2, strontium valency +2, fluorine valency -1, chlorine valency -1, barium valency -1, iodine valency -1, oxygen -2, sulfur -2, selenium -2. Do you understand, everybody? So what is that? Valency. So valency less, more faster reacting or slower reacting? Everybody. Yes? Do you all understand, Amma? Please respond. Everybody?
Yes, sir.
So valency is less, more faster it will react. So that is why you can see sodium and potassium and all highly reactive, more reactive than calcium, magnesium and all. Okay. So that is what even 10th class will get metal activity series. Like based upon the arrangement of metals, like reactivity of metals, we'll arrange them in a proper order. So that is what metal activity series will say. So we'll study that. So that's the significance of a valencies. Okay, everybody? All of you understand, Amma? So this is what is call it as valency. Now, for example, I will check it. So now, for example, let me check the what is the valency of aluminium in aluminium oxide. They are asking. What is the valency of aluminium in aluminium oxide? Mr. Mugesh, don't know the chemical formulas. So please learn first. Oxide, oxygen, hydroxide, OH. Chapter number 3, there is a tabular column, most important tabular column. I told you, you all should learn that compulsory, everybody knows. Next offline is coming Saturday, I will check it. Again, I'm saying you, without knowing that, you cannot do anything. So that is what you have to remember. So valency of aluminium in aluminium oxide. So we all knows that. So here if you notice it, in this molecule, observe, this is a molecule actually. Aluminium oxide is the molecule actually. Now if you notice it here, three oxygen atoms combine with the, how many aluminium atoms? Everybody? Three oxygen atoms. Please respond, everybody. Three oxygen atom combine with the, how many aluminium atoms? Everyone? Yes? Speak guys. Two
Two
aluminum
aluminum.
atoms combining with the how many oxygen atoms?
Three
Three
oxygen.
oxygen. Means one aluminum atom combined with how many oxygens? Anybody can tell? One aluminum atom combining with the how many oxygen atoms? Two will come this side. What will become? 3
By
by
two.
2. Do you understand it? So one aluminum atom means the oxygen atom combining with the one aluminum atom is 3 by 2 of oxygen. Fraction I'm saying. So, and if you have noticed it, the valency, if you have been check it like that. So totally, how many aluminum atoms are reacting? Everybody? How many aluminum atoms are reacting? Yes, please. One aluminum atom, 3 by 2 oxygen. Now totally how many aluminum atoms are reacting?
Aluminum.
How many aluminum atoms are reacting, guys?
Two aluminum.
Two aluminum atoms. I'm trying to make a procedure, that's all. So you can notice it. All of you observe. So the valency of aluminium is actually how many aluminum atoms are involving? Number of aluminum atoms into amount of oxygen are reacting. So number of aluminum, how many? Two. Combining oxygen with one, how much? 3 by 2. So if you make it oxygen, you avoid 2 will get cancelled. So what is the aluminum valency? Everybody. What is the aluminum valency? No need this and all. Just I am saying. What is the aluminum valency? 3. Clear? So generally remember, we all know aluminum and oxygen. So aluminum valency is 3. Oxygen valency is 2. So if you have been done the crisscross method, by using a crisscross method, we will get Al2O3, aluminum oxide. Means two aluminum atoms combining with the how many oxygen atoms? Everybody. Three oxygen atoms. That is what you have to remember. So please. Next, if I take valency of carbon in CH4, anybody? Valency of carbon in CH4. What is CH4? CH4 means what is that, everybody? Methane. So what is the valency of carbon in methane? Anyone? Here hydrogen is not donating, hydrogen is receiving. So what is the valency of carbon? Everybody. Carbon atomic number is 6. Understand? Hydrogen atomic number is 1. So atomic number here K1, here 2 comma 2 comma how much? 4. So what is the valency of carbon? Everybody. Valency of carbon, speaking only correct, it will
4.
come. Simply sitting like a dumb fellow, so what is going to happen? 4. So, and hydrogen valency is 1. So that how many hydrogens is needed, everybody, to combine with the carbon? How many hydrogens is needed, guys? 4 hydrogens. That is what? CH4. So what is the valency of carbon? 4. So how it will forms like this? 4 hydrogens will combine with the carbon. That is the structure of methane. So each carbon will combine with the 4 hydrogens to become stable in nature. That is what you have to remember. Do it now. Clear everyone? All of you? Yes, please. So every element, it will, what is the purpose of this sharing electrons? To become stable in nature, to acquire the stability. To acquire the stability only, they will share the electrons or they will receive the electrons. That is you have to remember. Understand? Alfin, Abirami, Hasini, clear everyone? Any doubt, please let me know. So whatever the element is donating the electrons or receiving the electrons or sharing the electrons, only to become stable in nature, only to acquires the stability. That is only the purpose of this. That is what you have to remember. Okay, everyone. So this is what is about valency. Valency means how many can donate or how many can accept or how many can share during the chemical bond formation. That is only call it as valency. So anyone having doubt, please ask me. Otherwise, we will finish it. Go to the next concept. So if you are having 8 electrons in its, what is the rule we used to call everybody? What is the name of that rule we used to say to satisfy?
Octet rule.
Octet rule. So octet rule we used to say. So octet rule will get only by either receiving electrons or donating electrons or by sharing of electrons. That is what you have to remember. Valency means it is the combining capacity, how much it can donate or receive or it is share. That is what we used to call it as valency. So now we are going to discuss types of valencies. So that is what, if it is donating, what valency, if it is receiving, what valencies, and donating and receiving and sharing. So that is what, based upon that, this is the most important concept. So types of valency. Again, 10th, 11 and 12 also will get it. So types of valencies. So based upon the like donating, receiving and sharing electron, types of valency is classified into 2 types. One is first one, electrovalency. Electrovalency. Mari, not 1 into 4, Mari, valency 4. Because it needs 4 electrons to become stable in nature. Do you understand? So we can say 4 it is, not 1 into 4. Understand, Mari? Yes? Because it cannot lose the 4 electrons. Carbon cannot lose the 4 electrons. And carbon cannot gain the 4 electrons. So it will share 4 electrons. Yes. So it will share 4 electrons with every carbon, every hydrogen atom. Every hydrogen atom can share 1 electron. That is what. Okay. Understand? Everybody? Niroshi, Agalya, Alfin, not ready to speak, not ready to respond, no need to attend. I'm very, very serious. I'm not going to excuse anybody's. Everybody. Electrovalency. So write it. At least chart you have to make it. Write all of you. The number of electrons gained or lost. The number of electrons gained or lost. Electrovalency. The number of electrons. The number of electrons gained or lost by an element by an element in order to complete, everybody take the notes. I know many people are cheating me. Complete its octet rule. Octet is known as its electrovalency. Now, by this time, you understand. Share gaining and lost. Gained and lost, we used to say, is between what? Metals and metals, or metals and non-metals, or non-metals and non-metals. Everybody? Yes, please. Gaining and losing. Metals and metals, or non-metals and non-metals. Yes, please. Clear, everyone? So tell me, electrovalency means we'll speak about what? Only metals and metals, or metals and non-metals, or non-metals and non-metals. Somebody is donating and somebody is receiving. So who else will comes? Everybody. Yes, please.
Metals and non-metals.
Metals and non-metals. Because non-metals need to receive the electrons and metals need to donate the electron. That is what you have to remember. Clear, everybody? So write it, everybody. First, ions. Ions are two types. What is ions are two types? I already taught you. What is ions? One is cations and another one is what?
Anion.
All of anions. Remember, cations, positive charge, anions, negative charge. Cations will form by loss of electrons. Anions is formed by gain of electrons. Note it, everyone. Clear, everyone? Carbon is not electrovalency, Mari. That's what. Sharing of electrons is different. I'm going to say you that. That is secondary. Okay, I will teach. Just wait. Do you all understand, everyone? All of you? Yes? So, who will donate the electrons, basically? Metals will lose electrons. So they will form what? Everybody. They will form what? Cations or anions? Cations. Yes. Non-metals will receive electrons or gain electrons so that they will form
Anion.
anions. So that is what you have to remember. Any doubt? Anybody can ask. Clear, everybody? All of you? All of you understand, Amma? Okay. So that is what. Now, so whomever going to donate the electrons, metals, note it, everybody. We are going to call them as positive electrovalency. The electrovalency of a cations, we used to call it as positive electrovalency. Next, metals who are non-metals who are going to receive the electrons, we used to call them as negative electrovalency. Clear? Any doubt? Anybody can ask. Lingesh, Kishore, negative electrovalency. So write it. Positive electrovalency means who will form? Metals or non-metals or?
Metals.
Metals.
Yes. Okay, note it. Clear all of you? That is what. Now example we'll take. So formation of sodium chloride. Write it. Example. So we all knows that. Sodium, what is the valency? Everybody? Sodium, what is the valency? 1. Am I right or wrong? Please respond guys. 2, 8, 1. So only one electron I will represent. Reacting with the chlorine. What is the valency? 2, 8, 7. So the chlorine wants to become stable. How many electrons it needed? Everybody. How many electrons needed guys to become stable? 1 electron. Am I right? You are not speaking what I should say. You people are like a dumb fellows. Keep on seeking, keep on everything. It is. Sodium 2, 8, 1. Valency. Chlorine 2, 8, 7. 7 electrons. So 1 is needed to become stable in nature. So that after sharing the donating electron by sodium, sodium will turn up into Na plus and chlorine will turn up into Cl minus. So that is how the sodium chloride will form. So that is what. So now what is the valency? 2, 8. Here 2, 8, 8. So this is what we is to say. Sodium is turning up into positive ion. That is what positive electrovalency. Chlorine is turn up into negative ion, negative electrovalency. Okay. Clear? All of you?
Yes, sir. Sir.
Do it. Understand? Any doubt? Anybody want to ask? Okay. So what is the electrovalency of sodium now? If they will ask you in exam, what is the electrovalency of sodium now? Electrovalency of sodium. What is that? Everyone. +1. And what is the electrovalency of chlorine? Everyone.
-1.
-1. That is what you have to write it. Hope you all understand. Till here any doubt you can ask. Understand everybody? Clear? Make it quick. Yeah. Any doubt, Ra? Gokul? Kishore?
No, sir.
Do it.
No, sir.
Next keep heading. Covalency. 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 So what is covalency, everybody? Now you understand. Electrovalency means donating and receiving. Covalency means what? Only by sharing. That is what you have to remember. Right. The number of electrons, meeting is going to end, join back. The number of electrons shared by an atom of non-metal. Who will share the electrons, Amma? Only non-metal and non-metal is called its covalency. Then the